Welcome to HP Tuner's GM Gen 5 training part 26. In this training module, we're going to be exploring the basics of our idle control. We'll find that the idle control is going to be a torque-based system. We're going to go through the tables, how it works, and understanding the concept of the torque-based control. Without further wait, let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at working with our idle control within our GM Gen 5 applications. This tutorial is going to be focusing on the fundamentals and the basics of idle control. It's a torque-based language, so things are a little bit different than our Gen 3, Gen 4s. We need to learn how that torque-based language is going to work here. There's actually much less setup and tuning that we have to do in a Gen 5 in terms of the idle control to get the idle speed right. If you've ever tuned a Gen 3, Gen 4 application with a big camshaft, you know the pain and how much time it takes to get things perfect with the idle control. There's still that level of flashing and trial and error here with the Gen 5, but it is substantially less. We can get an engine up and idling and running very, very quickly. It all hinges upon our airflow models being right, but as long as we've sorted out our speed density specifically, even the mass airflow, then we can usually get things going pretty quickly, and the idle control will fall right in line to what we want to program and work with. So let's jump in. I'm going to take a look at a 2018 Yukon Denali calibration file. That's the test vehicle that I have for our training course here. I want to go in and show you where you can find the idle control tables, and let's talk about what we have to program. Programming we have is pretty minimal, but let's understand what's going on in here. So we're going to jump into the engine tab here. We have general. Let's move across into idle. We have an RPM, and we have a torque subtab. Let's first focus here on RPM. We're going to talk about how the torque-based language works and the control works. It's actually really, really simple. And then we'll talk about our torque tab here and the couple tables we have to work with in here. So the first thing I want to do is talk about how the torque-based control works, what's actually going on behind the scenes. We can find here that in order to make the idle control function and start to work, we need to give it a target desired idle speed. This is going to be true for either a Gen 3, Gen 4. Those required you to get the airflow model right, so airflow-based programming for the idle control to function, whether it was the idle control motor or drive-by-wire movement on a Gen 3 or the drive-by-wire movement on a Gen 4, they're airflow-based. That's not the case here with the Gen 5. It is still going to be airflow-based in a sense because airflow drives torque, but now we're going to be dealing with languages of torque. Now in this particular case, we'll find that we just need to go in and set a commanded desired target idle speed. This gives an engine control module a point of reference that it's going to try to shoot for in its torque-based control. We'll find we really have a hands-off approach in terms of getting that desired torque right. The engine control module is going to work out what it needs for the torque on the torque language to hit our desired idle speed. So let's start to break this down here a little bit and discuss this. So this is our base set point. This is the base table that all the idle control is going to work from. We can find on the left side, we have different types of conditions: in gear, neutral idle, park neutral, reverse. There's also these different eco modes. And then at the top, we have engine coolant temperature. And we can find here, this is going to be programming where we want the engine to idle at. This is post-starting conditions. So cranking, firing off, and running, that's all handled from a cranking table and a startup airflow here. There's still an airflow-based type of language. We'll get into that in a specific tutorial looking at open loop startup type of conditions. We're just going to be focusing on how the idle control works. So we're assuming we've already fired off the engine. We're operating, let's say, at particular coolant temperature right here. This is now going to be where it's going to target the idle speed at. So in this case, let's just pick park neutral for my application here. Automatic. I'll be in park. I'll fire off the engine. Depending on what the coolant temp's at, it has this as the desired idle speed. So as we go from cold to warm, the idle speed drops minimally here, about 100 RPM. Now what this is going to do is say that if I want to idle at 700 RPM, the engine control module is going to take a look at the target idle speed. It's going to take a look at the actual idle speed, or what the engine's actually running at, and it's going to figure out the deviation or the difference. That's known as their idle RPM error, or the difference between the actual and the target. Now that error is what's used to drive the torque-based language and control in terms of trying to reach that desired target. So there's always going to be a fluctuation there. We might be overshooting, we might be undershooting. And how the engine control module is going to deal with the over or undershoot is going to be different, but we'll find ultimately what it's going to do is try to regulate what the torque output of the engine is going to be to hit the desired idle speed. And that's what we're doing for idle control in any other application.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.